Hello, in this video we will solve a slope stability problem using the Fellenius method to find the factor of safety. First things first, before applying the Fellenius method we have to make some basic assumptions. The first one is the assumption that the failure surface is circular. This implies considering rotational slides, which are common in homogeneous soils as in clays. The second condition is that the normal force acting on the failure surface at every point, it's assumed to pass through the center of the circle. The third condition is the assumption of undrained conditions. That is, the undrained shear strength is constant and independent of normal stress. The last condition is to take a two-dimensional model. In that way, we can assume for calculations a width of 1 meter along the slope. These assumptions are convenient. In that way, we can perform useful and quick stability evaluations in early stages of geotechnical design. The Fellenius method uses the following formula, which is factor of safety equal to the cohesion multiplied by the length of the slip surface, plus the tangent of the internal friction angle multiplied by the sum of the weight of each slice, times the cosine of its base angle, minus the pore water pressure times the length of each slice base. Then, we have to divide the entire numerator by the sum of the weight of each slice times the sine of its base angle. Now, let's look at the data of our problem, which is as follows. Slope height, 40 meters. Inclination, 50.4 degrees. Cohesion, 50 kilopascals. Internal friction angle, 30 degrees. Soil density, 25 kilonewtons per cubic meter. And radius of the failure surface, 40 meters. Now, we begin by drawing a height of 40 meters on graph paper at a scale of 1 to 50, that equals to 8 centimeters on our paper. Using a compass, we draw a circular arc with a radius of 8 centimeters, representing the potential failure surface from the base to the crest of the slope. Next, we divide the area bounded by the arc into 8 slices, or wedges, for our analysis. Then, what we do is to approximate the area of each wedge, using simple geometric shapes, as triangles, rectangles, or trapezoids. For each slice, we calculate the weight W by multiplying its area by the soil density, which in our case is 25 kilonewtons per cubic meter. We then determine the centroid of each wedge in order to find the angle alpha, which is the angle between the vertical and the line connecting the center of the failure arc to the line of action of W. This angle can be measured directly with a protractor or estimated using the following formula, which is alpha equal to arc sine of D over R, where D is the perpendicular distance from the center to the weight's line of action, and R is the radius, which in our case is 40 meters. All calculated values are compiled into a table, including weight, angle alpha, cosine and sine of alpha, and other intermediate terms using the formula. We also compute the total slip surface length using the following formula, which is L equal to pi times R over 2. Since it's a quarter circle and we have a radius of 40 meters, we get a value of L of 62.83 meters. Since there's no water in this case, the pore pressure is 0, and that term is excluded from the calculation. Now, we can plug all the values in the Fellenius formula and find the factor of safety for each slice. As we can see, after plugging in our values in the formula, we obtain a value of safety for the slope of 1.007. And that's how you apply the Fellenius method. Step by step, to evaluate slope stability and to determine the factor of safety. Thanks for watching.